Relax. Watch this. Thank you. Watch this, Cheng. Phone's away right now. Say again. Um, if I could what? Okay, got you. Um, watch this. Before I'm gonna do something more exciting than weighing him. We're gonna involve ourselves in logic. Um, now, obviously a scale right in front of your face, right here. Do you guys see what the symbol is? I put a little bootleg piece of paper on that. What is that? What does it say on that little piece of paper? What is it? What symbol is that? Thank you. It's an equal sign. Oh. Well, actually, you didn't guess it. You used inductive logic. In past experiences, well, when you said that's an equal sign, that was based on your past experiences, right? Ever since kindergarten, you saw the little that's equal sign, equal sign, equal. So now you saw it again. That's an equal sign. That's inductive logic. Now, but check it out. Watch this, Rivera. Let me get a little chip here. Watch this. Watch this. Right now, they ain't nothing on the scale. The right side and the left side are totally, what is that called again, Toscano? They're both what? They're both equal. They're both equal. Now, look what I'm going to do to the right side. Actually, I'm going to do to your left side, Martinez. And then to equal it, right? I had an equal amount on both sides, and what I did is I added the same amount to both sides, and it still stayed equal. That's just a law of logic that we all understand. If two things are equal, and I add one thing to one side, and I add another to another side, they're still going to stay equal. Watch this. Stay with me, guys. Watch. If A equals A, write this down with me. Hold on, real quick. Then, watch this. Then A plus B is equal to A plus B. What the heck happened from the if, after the if, to the after the then? What took place on both sides of the equation? So look at the if. There's your if. What happened from after the if to the everything after the then? What took place on both sides of the equation? So just look at the if. There's an equation, A equals A. What did I do to both sides? You guys are scaring me now. So look at the first equation. How about this? Let me cover that. Watch this. Look at that equation, A equals A. Compare that to this equation. What did I add to both sides? Thank you. I added the same amount. Look, in other words, I just did what I did right here. You guys, look. Watch. Here's A is equal to A. I added, look at this is B. I added B here, added B there. I can add whatever I want to both sides of an equation as long as I do it to both sides. That, ladies and gentlemen, is called the addition property of equality. It's just a law of logic. It's always true. It's obviously true. Who would disagree with that? A madman, maybe in a psychology ward with padded rooms in a straitjacket. Toscano thinks Martinez would? I don't think he would do that. Watch this. Let's go on the second law. Let's go on to the second law of logic. Watch this, Rivera. Write that down. The subtraction property of equality. Write that down. Subtraction property of equality. Come on, gentlemen. Are both sides equal right now? I would agree with Toscano. Both sides are equal right now. Look what I'm going to do to both sides. I'm going to take away, watch this, Rivera. I'm going to take away now the same amount. And if I do that, it stays equal. I took away the same amount. So watch this. Watch. If A equals A, look, it starts off the same. If A equals A, then A minus C equals A minus C. I took away the same amount. You guys, man. What? Hold up. Nice. I love it. You'll see right now. It's right down. Multiplication property equality. Red, I trust you're staying with us. Come on, man. We're on the third one. Multiplication property of equality says this. If A is equal to A, then what can I do to both sides? By what? By the same amount. Call it whatever you want. I like it. E. A times E equals A times E. I multiplied both sides by the same amount. No big deal. And like Toscano anticipated, this one's called division property of equality. Yep. Division property of equality. If A equals let's put if A equals B, then A divided by D equals B divided by D. I divided both sides of the equation by the same amount. As long as it's the same amount, you're good to go. Let's keep going. Last one. This is that's a B and a D, right. Last one is substitution property of equality. I'll write that down. This one's a little bit different. If A equals to B, then A can be substituted for B anywhere. If A is equal to B, then A can be substituted for B anywhere. Um, Let me give you an example of substitution. Remember this? If Gizmo equals a dingo hopper, then wherever I see dingo hopper, I can replace it with Gizmo. Look at, I can with that. Because look at, because A is equal to B, I can replace A with B anywhere. Look at dingo hopper right here, so I can replace dingo hopper with Gizmo because it's equal to that. And if Gizmo is equal to thingamajig, I can replace thingamajig with Gizmo. If the Gizmo is doodad, I can replace doodad with Gizmo. If Gizmo equals a puppy, then look at, that's exactly my conclusion. It's all substitution. If A is equal to B, I can replace B with A anywhere. So it's just a law of logic. Now let me show you this in action. Flip your paper over and go to example 1. Let's go to write down example 1. Better, you with me, right? Here we go. Given, prove. Given 3x plus 2 equals 17, prove that x equals 5. What the heck does that mean? Well, what it means is we're going to give a logical argument, and we're going to prove that x equals 5 with deductive logic. Right, watch this now. Ready? Go ahead and give me a table, put statements here, S for statements and R for reasons. Let me just put reasons here. And in the back of your paper. Yeah, statements. Do it in the back of the paper there. Come in, it's open. Yes. Got you. Put them. Oh, yeah, got you. Go ahead. Pass out. So tomorrow's open house, 3 stamps if you show up.
Is it really?
Be there, Reyes. Be there. Stop being greedy. Make sure you show up so I can talk smack about you in front of your parents. That'll be cool. Just kidding. Yes.
Wait, so are you giving 3 stamps on top of the already 4?
Nice. No, we'll go 4. All right, here we go. Oh, I thought you meant X. Wait, you're doing deductive. You're doing some deductive logic already. Here we go.
Substitute plus 2 equals 17 for 15.
I got a better idea. Just take notes and follow the master. Watch this. Here. First statement. Here we go. Statement 1. Go and write statement 1. Statement 1, we always start off with our given. Go and write 3x plus 2 equals 17. What is the reason that we wrote this? Well, the reason is it's given. So imagine yourself in a court of law where every statement you give, the judge asks you what gives you the right to say that. Right. No. In the back of the paper. Yeah, right in the back. Back of the law sheet. Is there a back? Is there a blank side? Do you have a blank side on that one? Oh, you know what? I gave you a copy that has something in the back. Just put it on the separate sheet of paper. This part. Okay. Every statement you give has to be substantiated and supported by a proper reason. Watch this now. What should we do to both sides to get x by itself? Good try. So subtract 2 from what side? What property did you just use? You're subtracting the same amount from both sides.
Property, subtraction, all easy things.
Nice. That sounded eloquent.
Subtraction property of equality.
Watch this. Toscano. You want to subtract the same amount from both sides, right? That's the subtraction property of equality. Look at what the property says. If A is equal to A, then you can subtract both sides from the same amount from both sides. That's a law of logic. That's what backs up your statement. So look what I'm going to do. Stay with me now. Watch. I'm going to write statement 2, 3x equals, hold on, 3x equals 15. What gives me a right to say 3x equals 15? Well, the subtraction property of equality gives me that right. That's my reason. Go right. Subtraction. I'm going to abbreviate property. Just put prop, period, of, instead of writing equality, just put an equal sign, because everyone knows that means equality. We're going to abbreviate so we don't get a hand cramp writing all these words. You with me, Rivera? You with me?
Yeah.
Getting worried, man. Just you're like walking around, everyone's like doing. You're just like. All right. Let's do this first before we do that. Here you go. Ready? What should we do now, Toscano, to both sides? Toscano's rocking and rolling. We're going to divide both sides by what? By 3, which is the same amount. I'm going to divide both sides by the same amount. What law of logic gives me that right? Well, look at x equals 5 then, because if I divide both sides by 3, x is 5. What gives me the right is the division property. I'm going to abbreviate division property of equality. We just proved that x equals 5 with a deductive logical argument. Here? Statements. Questions? Let's do one more. That was example 1. All right, example 2. Given go to write given and prove. So given, let's go 5x minus 5 equals 20. Let's go ahead and prove that x equals 5 again with deductive logic. I think tomorrow I'll have to separate you guys just during lecture time. And you guys can sit together during the assignment time. That's no biggie. I'm not going to abbreviate S and R. Just instead of writing statements, we're just going to put S and R because we're going to be doing a lot of these in the near future. So just put S and R. Statements, reasons. Let's rock and roll. Statement 1 is always your given. 5x minus 5 is 20. The reason is that's what's given us. There's no other fancy schmancy reason than given. I need some more coffee. You guys are tiring me out. What class? Got you. Martinez, what do I do? What do I do now to get x by itself? By what? Close. Chang, help him out. Because look at, we're subtracting 5 to the opposite on. So if I add 5 to both sides, what will result? Well, 5x equals 25 would result. That's my second statement. The result of adding 5. So that'll be, let's see, addition property of equality allows us to add the same amount to both sides. I added 5 to the left, 5 to the right, and it resulted in that. That's addition. I'm going to abbreviate. Addition property of equality. Again, abbreviate so you don't get hand cramps. Right, that's like, right, that's way back junior high, right? To get rid of it, right? To get rid of it on the left and bring it to the right. I'm just not showing the work. You got to do this in your mind. I'm adding 5 to the left and the right, and all I'm writing is what results from adding 5 to both sides. Notice that. I'm not doing the work. I'm coming to conclusions. And every conclusion is backed up by a legitimate reason. 3. What should I do now, Tapia, to get x by itself? To both sides right here. What should I do to both sides? Tapia. By what? Nice. That's what I'm going to do. I'll divide both sides by the same amount, but I'm only going to write the result of it, Toscano. Toscano, man. X equals 5. What gives me that right? Well, this gives me the right. The division property of equality. I gave an airtight argument. There it is, deductive logic. What I'm going to do now is give you one equation each. And you're going to go to Flipgrid and you're going to record yourself. Give me an argument. You're going to give me an argument. Okay? You're going to respond to my Flipgrid. It's on my Google Classroom. And give me an argument for one simple equation like I just did. All right. Chang, you're going to do this one. Nah. Given, you're going to prove that x equals 7. Okay? That's Chang's. Toscano. We haven't seen all of them yet. Toscano, you're going to go. That's given. You're going to prove. You're going to prove y equals 3. And Martinez, watch this. So G is for given and P is for proof. Martinez, you're gonna solve this one. 6z minus 7 is equal to 35. And you're going to prove that z is equal to 7. All right. Rivera, you're going to do the blue. Tapia, you're going to do the black. So Chang, you got blue. Toscano, you got black. Martinez, you got red. Rivera, you got blue. Tapia, you got black. Grab the computer, go to the Flipgrid, and you'll see exactly what I want from you. You may begin. Have a great day. If you don't get the Flipgrid in, you don't get your stamps. Just saying. Rock and roll.